let's say you have some fun JSON that looks like this, line delimited JSON. You've got a SKU, a product description, the price, the weight in kilograms, and then the dimensions in centimeters, one element for each dimension. And in Ibis 5.0, we're adding a kind of proper support for reading this kind of JSON data using DuckDB. And it's got all the nice features of like ibis.readcsv, where it will properly infer the types. So let's import Ibis. Let's set interactive to true, and we'll import the underscore API, and then we'll read in that JSON-L file, and we can just kind of do some quick uh, analysis here to see like how many lines it has. It's only got 10 lines. It's not super big. The latency for that startup was because was for creating the DuckDB in-memory connection, and then we have this JSON. We have this table of JSON rows, and so this is pretty nice. Like we wouldn't have to do much, right? If you wanted to look at the SQL, like it's just going to be reading from a DuckDB view. There's not going to be much there, but that view is created when you call read JSON, and something similar happens for read CSV and read Parquet. Okay, so let's say I had the problem of I wanted to convert the centimeters values into inches, right? So we can approximate this by dividing centimeters by 2.54. This is approximately 2.54 centimeters per inch. And like the way you might want to express this is some way of applying a function to every element of the array. But prior to 5.0, we didn't actually support that. So let's try and solve it without doing that first. So IPython completion is giving away the show here. But let's first define a function where we convert centimeters to inches. So we take centimeters and we divide by 2.54, and we can apply. We can't really apply this to anything yet, right? All we've done is define this function. Ideally, what we could do is say something like, oh, t dot, dims cm, maybe we could just call this and Ibis would magically figure out. But of course, you're trying to apply some operator division between an array column and a float, and Ibis is helpfully telling you that it doesn't know what to do with that. Um, so the next thing you might reach for is like unnest, right? Because that's going to give you a column of scalar values on nesting the array one level. So in this case, it'll give you that column, right? And it's going to give you, well, that's great. It's not going to, you can't count that. You have to actually project it out. So let's do that first. So that's 30 because there's 3 dimensions and there are 10 products. So it's flattening the array to give you 30 elements. Let's look at our table again. So you would do something like cm to inch, t dot dims cm on nest like that. And now you've got the calculation that you want, but you've lost the grouping that you had before. You can of course project that, and let's say you can overwrite dim cm with that. But now your table's got this cardinality, and it's a bit of a head scratcher. It's like, well, I have the same information here, but it's not organized in the way that I want. I want this original cardinality of the table, one product per row, but I want to apply an operator. I want to convert these centimeters into inches. We should probably call this dims inch or something like that instead. Because of course the dim cm column is repeated, so maybe we can drop that. Cool. Um, so there's a way you can do this that's pretty gross, and that is by treating every column that didn't enter into your inch transformation as a grouping key, and you can kind of do this conveniently with Ibis. It's a little gross, but you can give like the indices of the grouping keys. So you've got SKU, description, base price, weight in kilograms. And then you can say .ag, and you can say dimsinch equals underscore dimsinch dot collect. And let's call head on that so we only get a few rows. And we've successfully applied our transformation here. If we keep, um, yeah, right. So we've applied it. We've kind of applied our transformation here. So let's look at it again without the group by nastiness. And you can compare. You've got UG 27 cellular modem, 7.16 for the first dimension, and you can verify that that is in fact kind of the same thing up here. In Ibis 5, we've made this much easier and also more general. Like you can kind of apply pretty much any SQL operation that you want. You can apply that to your array columns. So let's look at our original table again. So let's say I just want to slap on dimsinch, and I want to say, and the way that you do this is with a map method on arrays. So let's just do it with the array itself and not roll it into the table just yet. So you look at map. It's got some examples. It's got a nice doc string. It takes a callable. And that callable is going to be applied to every element of the array. So in this case, I want to run my function cm to inch x. Sweet. That's all. I mean, I didn't have to do any grouping. I didn't have to do any of that nonsense aggregation after the grouping. I could just apply that function directly to the array. And the sort of anything that would be sort of applicable to a scalar function, you can do that inside of this lambda. It's not running arbitrary Python code. It's actually turning this lambda into SQL. And of course, we don't need that argument, so we can just pass that directly. And of course, like now that we can do that, we can just mutate that column in there directly. Still got my centimeters. Let's call head again. Let's just look at the first two rows. And now we've sort of successfully applied, we've transformed our centimeters column into inches with a single line of code. We didn't have to do any grouping. We didn't have to do any aggregation. We just called map. Now there's a sort of a sister function on arrays that will filter elements. So let's say you wanted to get all products that have the first dimension bigger than 5 inches, let's say. So in that case, you actually want to apply the int transformation and then apply a filter to give you only the array, the products. Sorry, give you only the dimensions that are larger than 5. So you just call dot filter on that. You give it a same kind of thing. You give it a lambda. You give it any callable that's sort of gonna turn into an Ibis expression. And now we've shaved down that array. We've got, this is showing that there's one dimension that's bigger than 7 inches, and it's a modem. And our mechanical tuna crusher has 2 dimensions that are bigger than, sorry, not bigger than 7, bigger than 5. And so this gives you a lot of flexibility when working with arrays, because you can kind of filter and apply functions to those arrays without having to do a bunch of like intermediate grouping and aggregates and so forth. So that's kind of the main thing I wanted to show on this stream, other than the hilariously bad audio and video situation going on. But for those of you who stuck with me, thanks for tuning in, and I will see you next time.